In this video, we are going to have an introduction to alkenes. Alkenes fall under a group of compounds known as the hydrocarbons, just like the alkenes. So that means under alkenes, we shall basically be having carbon and hydrogen atoms only. We should not expect sulfur, we should not expect nitrogen, and so on. However, what makes alkenes unique from other hydrocarbons is that alkenes always contain at least one double bond between a pair of carbon atoms. So they will always contain a double bond, a double covalent bond. So the double covalent bond is always represented by two dashes and then between two carbon atoms. So we shall always be having our double bond between carbon whenever we are dealing with alkenes. However, you can also use a general formula for the alkenes to be able to predict a given formula or to be able to draw a certain structure by knowing the number of carbon atoms and the number of hydrogen atoms present. So the general formula for alkenes is CnH2n, where our n will start from 2, we cannot have 1. Try to find out why we cannot have a value of n is equal to 1 in this case. So our n is always equal to the number of carbon atoms. So n is also the same as number of carbon atoms because our n is next to the C in that general formula. So with this general formula, we shall always be able to predict the alkenes that we can form. Okay, let's continue from here. Let's now have a look at a scenario where the n value is equal to 2, because we have seen we don't have n is equal to 1. So for n is equal to 2, we shall have to use our general formula CnH2n to predict the molecular formula of this compound. So we shall have N2H2 times 2, and then we shall obtain C2H4. So this will be the simplest alkene possible because the first n value can be 2. We can't have a scenario where we have n is equal to 1. So this will be our molecular formula for this compound. Remember, we also have a general naming for hydrocarbons. So when we are to name this, we shall have to give it the prefix eth. But it being an alkene, we shall then add ene. So this compound or molecule is known as ethane. So ethane has a molecular formula of C2H4. One of the most important things concerning ethane is that its molecules can combine with other ethane molecules to form a very long chain that we usually call polyethane. Poly meaning many, polyethane. However, it's usually written as polyethane without the e, polyethane, a very common plastic in our everyday life. So ethane has the ability to join with other ethane molecules to form this common plastic known as polyethane. So when you look at our displayed formula for ethane, we shall have it as follows. So our displayed formula, we shall have to have the two carbon atoms and the double bond, because we say the double bond is the functional group for these alkenes, and then we shall have the 4 hydrogen atoms attached 2 to each to ensure that each carbon atom ends up having 4 bonds. So this will be the displayed formula for ethane. However, we can have a condensed structural formula or basically structural formula where we shall have it written like this. So our structural formula can be represented as follows. When you look at structural formula, we shall look at our displayed formula. The first carbon atom has 2 hydrogen atoms, then we have our double bond and then our 2 hydrogen atoms. This can be the structural formula of ethane. However, sometimes it's also preferred to write it as H2 carbon to show that the double bond is between 2 carbon atoms. So this is our ethane. Let's now look at a scenario where we have n is equal to 3. So for n is equal to 3, we shall still have to substitute into our general formula. N is equal to 3. Our general formula is CnH2n. So when we substitute, we shall obtain C3H3 times 2, which will be 6. So this will be the molecular formula of the second alkane. Remember, molecular formula shows the number of atoms of each kind of element present in that given molecule. However, when you look at the displayed formula, here we shall have to show the bonds. So we shall have our 3 carbon atoms, 1, 2, 3. We shall have a double bond between at least 2 carbon atoms. As we said, this general formula basically works when we only have 1 double bond in a given compound. So this carbon atom will need 2 more bonds. We shall give it 1, 2. So this one has all the 4 bonds. Then we shall have 3. This second carbon atom, we give it another bond, and then this first one will also have 3 hydrogen atoms. So this will give us a total of 6 hydrogen atoms. However, the structural formula can be written as follows. Structural formula. Still we get it from our displayed formula. The first carbon atom has 3 hydrogen atoms, so we shall write CH3. Then the second one has 1 hydrogen, CH, our double bond, and then CH2. But still, like I said, we can also try and ensure that the double bond is between carbon and carbon. So this will be the condensed structural formula of our alkene, whose value of N is equal to 3. In terms of naming, we said for all hydrocarbons where N is equal to 3, we shall have to give it a prefix, of prop. So since it's an alkene, we shall also give it a suffix of ene. So the molecule that is formed when our value of N is equal to 3 is called propine. So this one is known as propine. The prop comes from the 3 carbon atoms, then the ene comes from the name ending, because one thing to note is that all alkenes will have a name ending that we forgot to talk about when we are looking at ethene. They'll have a name ending of ene, just as it is seen here. Lastly, let's look at a scenario where we have N is equal to 4. Let's now look at the last case where our N value is equal to 4. So for N is equal to 4, we shall still substitute into our general formula, and then we shall obtain C4H. 2 times 4 is 8. So this will be our molecular formula for N value is equal to 4. However, when we are to look at our displayed formula, remember, displayed formula will be able to show you the bonds or the orientation of the molecules. So we have the displayed formula. So in our displayed formula, we shall have to first write our 4 carbon atoms, 1, 2, 3, 4. Now we have to place a double bond somewhere. Let's place it between these first 2 carbon atoms. So that's our double bond. This means that the first carbon atom will have 2 bonds, and then needs more 2 bonds to form the 4 covalent bonds needed by carbon to be stable, while the second one needs 1 hydrogen atom. The third one will need 2 hydrogen atoms to have 4 bonds, while the last one will need 3, so that can also have 4 bonds, which will make a total of 8 hydrogen atoms, just like it is showing in the molecular formula. However, take note that our double bond can be placed between carbon atom 1, carbon atom 2, just like it is in this displayed formula. However, it can also be placed between the second and the third, or between the third and the fourth. However, to keep it simple, we shall look at only this scenario where our double bond is between carbon atom number 1 and carbon atom number 2. When you look at the condensed structural formula of the same alkene, we shall realize that condensed structural formula. So we shall realize that we also get it from our displayed formula, whereby our first carbon atom or the fourth carbon atom has 3 hydrogen atoms. So we shall write CH3. Our third carbon atom has 2 hydrogen atoms, so we shall write CH2. Then the second one will have 1 hydrogen atom, we write CH, followed by our double bond, and carbon atom 1 will have 2 hydrogen atoms attached. So this will be our condensed structural formula. And when naming this alkene, remember for n value is equal to 4, the prefix we use is but, while the suffix will always be ene, ene. So this compound here will be known as butene, just like we had ethene, and now we have butene, we had propine, and so on. However, take note, we did not have a scenario where our n is equal to 1, because you will be like, if I substitute for n is equal to 1, I'll have C1 H2 times 1, and then I'll have CH2. This cannot exist, as such we don't have an alkene with n value is equal to 1. So this is butene. We shall stop here, try and find out other alkenes, maybe from n is equal to 5 up to n is equal to 10, and try and write down their corresponding molecular, displayed, and condensed structural formulae. See you next time. Thank you for watching. In case you haven't checked out the video concerning alkenes, please do so. We are now going to look at alkynes in our next video. Stay safe.